I'm Alex, and I used to work as lead of Scala plugin for IntelliJ, and now I decided to learn a bit Scala Native. When I switched a year ago to Kotlin Native, I started to develop IDE for Kotlin Native because I needed something new after 9 years of Scala plugin. And I found it pretty interesting stuff, but from January I moved even for bigger horizons to Kotlin tooling team at all. So I'm now leading Kotlin tooling team. And I wanted to learn something around Scala Native, and that's why I decided to give a talk for Scala Days here. And I really appreciate that program committee accepted this talk here because Kotlin is definitely competitor for Scala. So it's no doubt. I mean that if somebody can tell that Kotlin, if somebody tells you that Kotlin is not a competitor for Scala, it will be kind of a lie. Because you know, the same field, the same people trying to do this stuff. So definitely right now Kotlin and Scala has different markets. I mean that Kotlin completely in Android market and slightly in web stuff and different things. And Scala is widely used in lots of fields, and it's a very mature language. I still really love Scala, do some Scala, and that's my favorite language. So I decided to do some kind of comparison to understand what's going on. So let's start from some sad news, and especially with yesterday's talk around Graal VM, this sad news is even more sad around Scala Native. So that's kind of Reddit message. Somebody asked about can Scala Native keep pace with Kotlin Native, and answer is actually that yeah, it's hardly possible because Kotlin Native team is quite huge. It's more than 8 people working just on the backend stuff and interoperability stuff, and they are very professional native developers, came from native world. And not so many people works on Scala Native, so it's really hard to compete, especially in the technology which can be widely used. And I show you some examples where it can be used actually. And together with yesterday news around Graal VM, when we can see that speed of Scala compiler is much faster, so we can see that purpose of Scala Native is even lower. So let's try to understand what's going on next in the talk. So why native? So first thing is startup performance. Everybody knows that we are trying to change our architecture of programs into smaller parts, so microservices, and it's definitely important for microservices to start up faster. And that's why one of the biggest purpose of native, using native. So we know already that people started using for Amazon Lambda, for example, like Scala JS, because startup time is so fast, so we can run our functions there as small microservices. So native can be also a possibility for that. So another is, it's very questionable bullet, but it's questionable about questionable JVM platform future. So it's my personal opinion. I mean that we just don't know what will we have with this kind of thing. Especially again, they already do a different VM, which is multi-purpose and multi-languages and so on. Another also bullet is general performance. Mainly for Scala Native and Kotlin Native, general performance is not the main purpose because it requires lots of effort working on performance, lots of hours for performance engineers improving final bit code. and that's not the main purpose, and so that's why it's questionable still, because even hotspot with JIT is very fast actually. It's highly optimized code, so its performance is really good. So that's the next one, is possibility to run programs on iOS. So that's what we didn't have with Java. So that's we actually have it, but it's kind of tricky thing, and the same for Scala and Kotlin. So iOS native support is kind of possible thing. And the last one is possibility to run on embedded devices. That's also the world is changing right now. So for example, on last week on Google I/O, we saw the presentation around Android things. I mean that people already do devices with Android things, so they can use all this Java, Kotlin, and a bit Scala stuff, use ordinary Android apps on that places. So this is also very big competition is going to be there, and so embedded devices, we can talk even about more small devices where latency is critical. I mean that program should be very predictable. So small devices on small microschemes with low CPUs and so on, with no OS. So that's possibility again. That's not that was actually works. So that's answer to the question why we want and need these technologies. So let's do some introduction. Generally, around this talk, I'm not going to give some deep explanation around these technologies. So I want to do some introductory talk and do some bit comparison. So let's take a look for simple Hello World projects. So that's quite simple, but we need to run in terminal. So I mean that nothing is supported yet in IntelliJ. If I run by this button, I'll run ordinary JVM. So and in terminal we need to run like SBT native link. Then we will see how compiler works, and then we will get actual binary. In this example, I have two main methods, and for Scala Native it's important to choose the right main method. So we need to choose the second one. Then it will optimize and do that code elimination in the final binaries. It's a bit slow, but usable. So now we can see this binary and go to the actual, and for example run this and see the println, which is instantly. So that's original goal, to have a instant startup time. Pretty similar in Kotlin, but here we have some IDE support, so we can just run it and see this Hello Native world. It don't use some tricky stuff like Gradle or SBT. It uses old-fashioned CMake. It's a bit weird, but everything is, of course, it's going to be on Gradle mostly, because you will see why. Okay. So right now it's kind of scary CMake script, which builds and runs this stuff. So initial comparison of these simple two things is about binary size, which is very different. We can try to pack it with UPX and see the difference, which is still, you know, I want to say that 4.2 megabytes for Hello World, it looks like too many, but actually it's very impressive work, believe me. And Scala is very heavy language itself, so that's why it possibly collects too many things inside of. So in Kotlin native, for example, runtime library is much smaller, and that's probably also the reason. And println time, it's, you know, it's very simple benchmark, which also can be wrong. So, but don't see it like Kotlin native is pretty better. No, it's just some numbers. And compilation plus linking time shows that we need to do it for after any change. We need to do it constantly. So developing in Kotlin or native or Scala Native will cost some time. I mean, we know that in Scala and Kotlin world we have such thing like incremental compilation. So for every change we can see running tests in probably 1 or few seconds. That's really productive. So when it's more than 10 seconds, it became less productive. So that's what I told just around incremental compilation, and we see now that both compilers are slow. So our big competitor, which is GraalVM, is already faster, but still incremental compilation is going to be an important thing. I mean that we can do something incrementally. For example, what is good around Scala Native, what is not implemented yet in Kotlin Native, that Scala Native has some intermediate representation before actual compilation. That's good thing, because this intermediate representation is possible to serialize and publish as libraries. What is much more complicated in Kotlin Native, where intermediate representations is only coming. So I mean that it's under development, but not yet ready. But of course, the idea is completely the same. We want to have very similar thing to Tasty and have a possibility to distribute libraries in serialized backend intermediate representation. And this parse definitely could be incremental. It's already incremental in JVM world, so it's not really complicated to do it incrementally than in native world. So the second part requires compiling from intermediate representation in the binaries, and even more complicated thing is linking. Of course, some things can help in this direction, because we can do dead code eliminations on intermediate representation, and then linking will be much faster. But still, linking is very slow thing in native world. So how it's implemented in GraalVM is quite impressive again. So speaking about startup performance, we can understand one of the possible purpose which we as developers already want to have, and do it, for example, in JVM world. We do some command line tools. But in JVM, if we want to do some command line, we still need to wait for starting this JVM stuff. So this startup performance makes a good idea to have a Kotlin and Scala Native for command line tools. And good thing around Scala that part of GDK, not GDK, Java standard library is implemented in Scala. And good thing is that a lot of libraries already possible to compile for Scala Native. And that's not the same for Kotlin, because Kotlin don't have Java library in native world. So that's a trade-off, kind of, because if you have a implemented Java standard library for one particular client like Linux, then you already have lots of libraries. But then supporting new platforms means that you need to re-implement lots of this stuff for different machines. And this also means that you can get some differences in implementation, so bugs and some problems with compatibility. So Kotlin doesn't have it, because we don't want to deal with this complicated stuff, and we want to have lots of supported platforms already. So what we have in Scala, we have some library, for example, Scalab, and that's some simple code which is I called calculator, because you can do plus and multiply two numbers, and now you can do it from terminal. First we need to compile it again because it's another main entry point. Okay, something is broken. Oh, okay, so thank you. We need to do it again because entry point is important for in native world, because we need to do some optimizations for the final binary, and one of them is that code elimination. So if you know an entry point, we can remove unnecessary classes. So now we have new binary, and we can run it. So we can do any calculations we want, like operator sum, and do like 12 and 13. So we can see that it's 25. It's right. So software works. And in Kotlin we can see much more scary stuff. So this is kind of CSV parser. It's also command line based. So, but we need here to parse arguments by ourselves. This is pretty simple arguments parser, so which just takes all the arguments one by one. You of course can use native library, which is getops. And this is kind of tricky thing, especially for Java and Scala. I mean not Java, Scala, but JVM developer who don't know this scary native world. But it's possible because of very major interoperability feature supported in Kotlin native. I mean that you can actually call the native libraries. Of course, you will lose this Kotlin runtime, which is available inside of Kotlin itself. And you need to deal with memory as you usually need to do it in C and C++. So we need to define this memscoped scope where we can alloc memory, and so that's how it works. So here we do some IO stuff just to read the file. So and we can actually run it. And here we have some predefined parameters and some predefined CSV file which is parsed and did some stuff around that. Okay, pretty cool for now. Actually, in Kotlin, during the probably 2 weeks ago, a new library were implemented around parsing arguments, so it's already available. But I mean that in Scala, it's much more than one library already available. So that's what is cool about around Scala Native. So what's next? I already started speaking about memory management. So the big difference between Scala and Kotlin that Scala is GC-based memory management, as well as Graal VM. So Kotlin has different ideas. It has referent counter with cycle collection memory management. And memory is separate for every thread, and cycle can be collected inside of every thread. So world is not stopping when some thread is deciding to collect cycles, and this is very lightweight. But generally it's just reference counting. And what's the strong thing around reference counting, I will show a bit later. Actually, if we want to speak around science, that is just two different possibilities to implement this garbage collecting. And science tell us that actually it's possible to do the same the same performance from both sides. So all these options are right, actually. I mean, according to the site, we can go from the reference count point to the same point as GC base, so performance will be pretty the same. So the purpose of reference counting is mainly iOS development. Why it's important? Because we want to have a good interoperability with native languages, and for iOS, native is Swift and Objective-C, which actually has no garbage collector. They have reference counting memory model. So that and they also have API for reference counting. That means that if our runtime we want to join with native iOS runtime, we need to do these interoperability things. And if both runtimes are reference counting, then when we pass object, we can wrap it into some iOS wrapper. And if we get objects from the Swift, we can use this reference counting through the API. So that's very simple and straightforward. What is not, and that's not obvious what to do with garbage collector things. So that means that most probably, if you want to run some program on iOS, you will do everything on your own without reusing some native libraries. So that means lots of complications, and that's why Kotlin Native is now on the iOS. It's going to be, of course, a competitor to GraalVM, but again, right now we are going to finish this technology for cross compilation between Android and iOS, and having cross compiled business logic between these two platforms. So that's the most interesting thing around Kotlin Native, because we have own purpose and we want to reach some point, so we know exactly what to do, what to implement next for this technology. And native world is quite wide. I mean that lots of new things exist around that. So one of them is actually also preview technology, which is WebAssembly. And Kotlin Native already has experimental support, but it's just verification of possibilities of Kotlin Native runtime. And again, reference counting shows that it's quite nice, and Kotlin right now it's probably the third language supported for WebAssembly after C and Rust. And WebAssembly is very interesting technology. I think it will be widely used in the future instead of JavaScript. And the last possible promising target is embedded devices. And what I want to say that it's very conservative market, because some problems or bugs means losses in millions of dollars. So that's why managers don't want to switch technologies from one to one. And also, for speaking about language itself, I mean Scala Native or Kotlin Native, it means that you need to put a lot of effort to support different devices. You can choose a single device like STM32 and try to support everything, but market it will be so small, so it's really hard to understand if it's suitable to do that or not. I mean, for example, compared to iOS market, which is much bigger. So and just some play of words for the fun. I mean that, you know, the main difference between Kotlin, not actually main, but one of the biggest difference is which keyword to use for function definition. So this is fun of def with these two different keywords. So I can show you the right choice. I mean that it's another play of words, because right is def. I mean that's what we can see when we use on flights. So left is ABC and right is def. So pretty tricky play of words, but anyway, that's for fun. So let's do some IDE basics. What I want to show. So let me show. Actually, I wanted to show you some iOS stuff. I mean, this is application which we did for Kotlin Conf, and the most interesting is that it's entirely implemented in Kotlin Native. So all things like server, client, command line interface, iOS stuff, and Android, everything were implemented in the same language. So that's pretty nice. Actually, code looks a bit scary again because lots of usage of native libraries. I mean, when you use any native libraries, it means that it will be scary in any way. I mean that even in Kotlin or Scala, if we want to use, we can use native libraries because they have lots of years of development. I mean, lots of developers did so many things, so it's cool to actually reuse this stuff. But speaking about language itself, it definitely should have some wrapper library over this native thing. So that's what's going on here. So like we can use database like SQLite, which is also a very native library. So what I can show here is like debugging stuff. We can run, for example, server here, and we can put something like, okay, you can see that it's not stable. I put breakpoint and everything stopped. So breakpoint, you hit it here, and we can go to the from, and we can see here hit of the debugger, and that's so tricky thing. I mean the debugging stuff, which is very simply available in JVM. When we have Java debugger interface, so we can do lots of stuff with this interface and implement that. And in native world, we have AdultDB, so some scary words like dwarf and other things, and it's very low level. So if we want to put things into IDE stuff, we need to put a lot of effort. And we actually can do these stepping things, and even see here some data which you can see renders a bit slow. So we even can see objects and something inside of it. So speaking about IDE, we can see what is already works. As for Scala, front end, for example, IntelliJ IDE is already works because it's pretty the same like Scala for JVM. It also uses Java standard library, so we can just put JDK jars and everything will be fine with the Scala front end inside of IntelliJ IDE. And speaking about, for example, Kotlin, we need to remove this old Java stuff because Java library is lack of that, but Kotlin already has this presentation compiler stuff which is reused inside of IDE, so everything works more or less okay. So another thing is that actually what we can see in IntelliJ, I mean Scala, speaking about Scala, that here we have all the Java stuff like Java SQL here because it's hold the JDK added to the project. But actually, for example, for Scala Native, SQL stuff is not implemented, so that's kind of green code which should be red. And that's I think it's just small thing. I mean that in native world we can see libraries here. You can see like Java, Lang, and you can see this stuff like near native intermediate representation here. We also can see here some code which is available to analyze and reuse here. Actually, this is output stuff, but I mean that if we want to take a look into the native Scala, for example, we can see the library which has this native intermediate representation first of all, and we also have sources here. That's how it works also already. So we put into SBT dependencies for these libraries, and IDE can get them and see them as ordinary dependency like in GVM. And for binaries, we have this native intermediate representation, which will be compiled into the bitcode afterwards. So the only problem is that in Java standard library, which is used for Scala Native, we can see here Java lib here. So we can see that there is no sources here. So the problem is quite small. I mean, from the Scala Native perspective, we just need to rebuild the library to have these sources. But from the IDE perspective, it means that we need to avoid this GDK inside the project somehow. It's also pretty simple, but I mean that it's small things which requires a lot of vision. I mean, a lot of people working on that. So that's and one thing which is good. I mean that sources are part of binaries, and it's nice. But it's nice when the world is completely open source. But sometimes people want to share the library without sharing the sources. So that's another thing which is required to implement. I mean that the native intermediate representation should be decompiled somehow into sources, so IDE should understand this stuff from native intermediate representation. In Kotlin it's already implemented, as we are using compiler stuff for decompiling, and in Scala it will require a lot of effort. The same like we did for decompiling Java classes. And another thing is platform-specific implementation. So we have a Linux support, macOS, but no Windows. And one of the problems is that it's around requires some re-implementation of lots of Java libraries, and also it requires lots of effort of bigger team, because small team can support just one platform target and bigger team can do different things. So, and cross-targeting compilation is another point where we can cross-compile through the build system and to see this, to do very complicated multi-platform stuff. What is cool already in Kotlin, I hope that I do the both. I mean, I said what is cool around Scala and what is cool around Kotlin. But I mean that what is cool in Kotlin, because language supports multi-platform projects, so you can implement the core stuff and put somewhere expect declarations, and in platform specific implementations you can actually add actual implementations for these expected declarations, and that means you can design library which has common part, and this part will be dependency for your project, and platform specific parts will be added in the platform modules. So that's also what needed to be supported by in future. So the problematic place, as I already showed, is debugger. Debugger requires implementations for these low-level things, and in IDE it's quite a huge amount of work. Even simple thing like exception stack traces is already problematic. So let's try to do something live. For example, let's do another object, this function foo, which actually assert false, for example. So if we want to see the exception, we can call this c.foo. So let's do the link again. And see what we will see. So we will see actual stack trace, and it's already problematic because it doesn't have even information about lines inside of this stack trace. So debugging problems with exceptions is already a tricky thing. So let's run it. And we can see here this stack trace, but there is no source information, there is no line information. And it's very complicated thing how to put this into bitcode, and we need to also support from the binaries for the breakpoints. So that's one of the reasons why we chose C-line, because it already has some AdultDB support. So we did not so many things to already to have this breakpoint and stepping stuff. But we have this breakpoint and basic stepping, but no proper variables view. I mean, as you saw, it's slow and it shows these scary addresses instead of actual values. So it also requires lots of things, and full evaluate expression stuff. Not even full, even just probably call some function. So this is already quite a tricky thing inside of runtime of native stuff. It requires kind of reflect library, what is also becomes problematic because native world don't have reflection. So that's why our JVM world looks quite nice, because we have everything we would like to have, and in native it's very low level development. So that's all I wanted to share with you. What I want to tell you is that Kotlin native is actually has pretty good reason why this technology exists. I mean, it's tries to continue our market, which is Android developers. We want to give them possibility to share their code on iOS. So that's the main purpose of Kotlin native technology. And for me, it looks pretty cool even now. So it's in preview stage, and probably nobody uses it in production. People probably starts to try it just to see how it works. But it's already cool. Already lots of people wants to try. So that's why we are excited around this technology. But speaking about Scala Native, I really saw it's really cool. It looks nice, and a lot of effort already done for that. But I didn't find a good reason to which point it moves, because too many points we can reach. I mean, I showed embedded devices, WebAssembly stuff, iOS things, and for small team, it's even more important to choose this direction, exact direction. So, and with yesterday talk about around GraalVM, the future is even more complicated. I mean that it's simple thing, just not to do anything, and okay, let's take GraalVM. So that's the question is even more tough. The reason is required. So that's my thoughts. So thank you. Any questions?
Okay, thank you very much, Alexandre. Are there any questions? Yes.
Are there any plans to have a standard library that you could use across iOS or other Scala Kotlin native targets and Android and the JVM? Maybe a subset of what you offer on the JVM?
We are working right now on implementing different libraries, like for HTTP requests for serialization stuff, as well as coroutines, which is a library for multi-threading. So even these three things is lots of a lot for implementing lots of business logic around applications, mobile applications. But it's not going to be standard. I mean that it's from JetBrains, but anybody can implement similar things.